Hello and welcome to lesson 5. All right, so today we're going to start off, we're going to talk about multiplying binomials. So in the last lesson, we talked about combining like terms. You only want to add the numbers in front if the powers are the same on that letter. So today we're going to look at what happens when we multiply those kinds of things together. And the reason it's binomials is because we're going to be looking at two terms at a time. So let's go ahead and go over here. Oh, sorry about that. That line is up there from me doing a voice check. Sorry about that. I had to test to make sure we were good to go, which we are. So, a binomial is just an expression that has two terms. So, for instance, x plus 4 is a binomial. And so, when we were talking about exponents, we talked about how if you multiply two things and they have powers, and if you don't see a power, you can just assume the power is 1. We can just add those powers. So x to the first times x to the first, 1 plus 1 is 2. So we have x squared because there are two x's being multiplied. So we're going to keep this in mind as we move forward. So over here, we're going to have x plus 1. Okay, and we're going to be multiplying these together. From here on out, whenever I do the multiply sign, it's going to be a dot. Just because if I do this, that looks like an x. So this might not look like 3 times 2. This might look like 3x2, and we don't want to get that mixed up. So I'll just be using a dot. Dot means multiply. So we're going to be multiplying this guy times that guy. But before we do that, because that's a lot of things to be multiplying all at once. That's a lot of things to be multiplying at once. Let's just look at how distribution works normally. So what normally happens when we multiply numbers? Well, let's take a peek. So let's say we have 2 times 3. Okay, so you just multiply the 2 times the 3, get 6. No big deal on that front. But what happens when I add something to it? So let's say 2 times 3 plus 2. Well, according to PEMDAS, order of operations, I would add these first. So, 3 plus 2, that's 5. And then I would multiply by 2. So 2 times 5, that would be 10. So we know what that would be. But we don't have to do it that way. We can do it that way. And that would most certainly be a very easy way to do it. But it's not necessarily that we strictly do it that way every single time. So let's do something a little bit different. Let's multiply in first. And the law of distribution in mathematics states that, if you're multiplying something in, you multiply across your addition sign. So if we multiply across the addition sign, 2 times 3, that would be 6, as we said earlier. And of course, 2 times 2 is 4. And we keep the addition sign moving down. So we've got 6 plus 4 now. 6 plus 4 is 10. So as far as we are concerned, the law of distribution still works, still holds up. Happy day, we don't have to worry about that. But this can get a little weird looking when we're multiplying by more than just 2. So let's look at a slightly weirder version of this. Okay, so let's look at something like, so let's say x plus 2. Let's say we're multiplying that by 3. Okay, well, we're going to do the same strategy we just did a second ago. We're going to be multiplying these together. So 3 times x, that'll be 3x. And then 3 times 2, that's a 6. That's a plus sign. So we're going to keep that plus sign. And boom, there we go. Multiplication all done. Nice and simple and straightforward. But let's make this a little bit more complicated because, we're doing some upper level math here. So we got to make it complicated at some point. It's making too much sense. Let's do something a little more complicated. Okay, so let's say instead of a 3, let's say we're multiplying an x. Okay, well, x times x, as we established over here. X times x is x squared, because, this is x to the first power. That's x to the first power. So we get x squared. Then we do x times 2, so that'll be a 2x. Okay, so distributing that, not so bad either. So then we get into the more complicated stuff down here. We got, x plus 4 times x plus 1. Okay. Well, now there's a plus sign on both of these. So how am I supposed to distribute that? Well, there are 2 ways to do it. First thing we're going to do is we're going to go over the most straightforward way. And so in math, straightforward doesn't always mean easy. But we're going to start with the most straightforward way that we would do this. Okay, so let's say that we go, okay, so this whole thing is a number, because any expression is a number of some kind. So if we multiply this whole thing times x, that would be x times x plus 4. So I've multiplied it. I haven't simplified it yet, but I did multiply, the first number times the other number. And then I could multiply the other one by it. And if I do that, so plus sign in the middle, because plus sign comes down, I would then have 1 times x plus 4. So already this is a little bit messy because I'm distributing the way I did last time, except now I'm distributing something that's a lot bigger. So now I have to do the little distributions for each of these guys. So I gotta do, x times x, that would be x squared. Keep the plus sign, and then x times 4, that would be 4x. And now I have to do my distributions over here. So 1 times x, that would be plus x. And then 1 times 4, that would be plus 4. So all together, combining my like terms now, I have x squared, so that guy doesn't have a like term because there's no other x squares. Then I have 4x and 1x, so 4 plus 1 would be 5x. And then last but not least, I have my constant, which is just plus 4. So this would be my final answer of multiplying out that from the beginning. Now that was a lot of steps. That was a lot of little steps, little things being multiplied at a time. So let's look at another way to do this that is the same math, but it's not quite as lengthy because there's a lot of tiny steps. And the more tiny steps you got to make, the more likely it is that a small error will mess you up. So let's try to do this again, but a little bit faster, a little bit easier. So let's say we have x plus, let's say x plus 4 times x minus 1. So with the way distribution works, I know I'm going to multiply both of these guys by both of these guys. So that'll give me 4 terms total, x times the first 2, and then 4 times those 2. So there's a couple of ways that you can keep track of this, mentally organize this so it's not quite as difficult to keep track of. So what we're going to start with is a method called FOIL. So FOIL is an acronym that stands for first, inner, outer, last. So FOIL, FOIL. So first times first. So we have, x times x. Okay, that's going to be x squared. The inner terms, so the inner terms would be these right here. So that would be 4 times x. So positive 4 times x, I'm sorry. So that would be positive 4x. Outer would mean these guys right here. So x times negative 1, that's going to be a negative 1x. And then, of course, the last 2 terms. So now we got this guy. I'm going to jump over that. And then we got 4 times negative 1, so that'd be minus 4. So now, if we combine our like terms, so x squared has no like terms, so we just write that the way it is. 4x, and negative 1x, those are both x terms. So we're going to get a plus 3x, I'm sorry. 4 minus 1 isn't negative 3. 4 minus 1 is positive 3. Sorry about that. And then last but not least, we've got negative 4, which is, of course, minus 4. So this method is one a lot of students tend to like, and it's perfectly okay. It just makes it easy to multiply binomials a little easier. I misspelled FOIL. I misspelled FOIL. Well, we're going to use this as a teaching moment. Okay, so I misspelled FOIL because FOIL is spelled F-O-I-L. So it should be first, outer, inner, last. My bad on that. I misspelled that. But it just goes to show that even if you misspell the word like I did, you will still get the correct answer because it's not about what order they're in. It's that you have to remember to do all 4 of these. So you got to remember to multiply your first terms, your outer terms, your inner terms, and then your last 2 terms. So even though FOIL makes it easy to remember, it's okay if you do them a little bit out of order. That's perfectly fine. I'm sorry, I feel a little bit silly that I messed that up. I've done this so many times. It's just funny to me that one of the first times I messed it up is on camera. So that would be an easy way to do these binomials, is to just do the FOIL method. Now, but one of the things you might have noticed is that here when I was combining my like terms, I underlined them and I did tick marks. I did that so that it would be easy to see which ones were like terms. So whatever the power of x is, no, that's not true. What I just gave it a tick mark when I got something different. So x squared, that's a unique term. Something with an x, okay, that gets 1 tick mark, and then something without an x, that gets 2 tick marks. This is just an easy way to visually make it easier whenever you're combining your like terms. But it can also apply when you're multiplying binomials. So let's go ahead and look at how to use that to make multiplying binomials easier. So, and this is the method I prefer to use because it also works when they get bigger, because they do get bigger. But right now, we're just going to focus on some binomials. So x minus 3 times x minus 2. That's what we're going to do. So I know that this term needs to be multiplied by both of those other terms. So what I'm going to do is I'm going to start by underlining x times x. Okay, so that's going to give me x squared. Okay, fair enough. Then I'm going to underline my next term, and I'm going to make that x times negative 2. So x times minus 2 would be minus 2x. And now I've got both of my first terms. So now when I go to do my second term, I'm just going to put 1 tick mark under it. And so now when I multiply the negative 3 by my other terms, I'll just put a tick mark to let me know what terms I'm multiplying. So now I'm doing negative 3 times x, so that'd be a negative 3x. And I'll do that with a single tick mark. And now I'm doing negative 3 times negative 2, so I'll put a tick mark right there. So that'll give me negative times negative is positive. 3 times 2 is 6. So now I have multiplied out all of my terms. And I've fully multiplied it all. I know because everything has an underline underneath it somewhere. And the last one with the tick mark is what I see on the right. So I know I did everything. Now the cool part is that now that I need to combine my like terms, I can give this a tick mark to see that it matches up with that one right there. And I can give this one a second tick mark so that it doesn't match up with anything. Because, you know, now I've got my x's, now I've got my things without x's. It just makes the process a little bit faster, but you don't have to strictly do it every time. So, of course, we've got our x squared, who is all by himself. Then we got a negative 2x and a negative 3x. So we add those together, we get a negative 5x. Because we're adding, not multiplying. And then we get plus 6, which is all by itself. And would you looky that, there, it's all done. It's a nice, neat way to save a little bit of space. It's the way that I prefer to do it, but I completely understand why some people don't like doing it. Because, you know, it's looking at a lot of tiny tick marks, and that can be hard. So before we move on, there's one more method that I want to show you guys. This one's not my personal favorite, but I do know that it's helped plenty of students, so I am going to go ahead and showcase it. This is called the box method. Let's say I have x minus 3 times x plus 2. Okay, so if I'm going to multiply these, so I know I'm doing 2 terms by 2 terms. So what I'm going to do is I'm going to draw a box. And on top of that box, I'm going to put x minus 3, because that was my first term. And then on the right-hand side, I'm going to put, or the left-hand side, sorry, I'm going to put x, and then it's x plus 2. Okay, so now I'm going to split this box into 4 parts. And it's 4 because it's a 2 by 2 box. So now, if I want to get this box, I have to do this number times that number. So x times x would be x squared. So that's what goes in this box. So now if I want to get this box, I need to do the negative 3 times the x. So that would be negative 3x. Excellent. So, and then, of course, if I want to do the one right here, I need to do the positive 2 times the x. So that's going to give me a plus 2x. And then last but not least, if I want to get this last box over here, I got to do negative 3 times positive 2. So 3 times 2 is 6. And then positive times negative is going to be a negative number. So now I've got all of my terms. And a neat thing about the box is that, at least when you're doing it with binomials, these guys are my like terms. So it makes it much easier to keep track of. So on the top left, I've got x squared. It's got no like terms, so I don't got to worry about it. Meanwhile, for my next term, I got negative 3x plus 2x. So it's going to leave me with a negative 1x. And then, of course, just minus 6. And these are the main methods you can use to multiply binomials. I would actually recommend that you kind of pause the video here and then just try a couple of them out. so that whenever you go to, practice them yourself on your own, you can see them and follow along with each method, and then just try one or two. As you can see, I was just making up a bunch of examples by changing these numbers. So just change those numbers to whatever you want and give a couple of them a try. That way you can find the method that works best for you. Because like I said, I don't personally use the box method very often, but I know that there are plenty of students who do use the box method. There are also plenty of students who use FOIL, and some students like to use the method that I do with the underlines and the tick marks. Whichever one is most comfortable for you, I would recommend using that one, because pretty much any of these can be used going forward. It's just a matter of which one you prefer. So that is pretty much it for multiplying binomials. And there is something I want to check real quick. Yep, I did it in here as well. I spelled I did first, inner, outer, last. It's supposed to be first, outer, inner, last. That's my bad. So it's FOIL, first, outer, inner, last. Dang. Well, sorry I misspelled it. But the good news is, with FOIL, it doesn't matter if you mix up the two on the inside. You'll still get the right answer. So don't worry about messing it up like I did. You'll still get the right answer. That's perfectly fine. So next up, after just multiplying binomials, now we're going to look at squaring binomials. So when you square a binomial, it doesn't quite look like the way you think it would. So let's go back to the board for a second. So when we have a binomial, as we discussed, it's two numbers being added or subtracted together. So let's say we have x plus 3 squared. Now, a lot of students, and I'm going to put this in pink, I'm going to say wrong. So a lot of students, and I mean a lot of students, when they see this, their first instinct is to distribute the power. They think that that is what you're supposed to do, so we'd get x squared plus 3 squared. That is wrong. That is not how that works. Not at all. And I will show you why it doesn't work that way right now. So we're going to say that x is 1. And this is a good way to check something. If you're not sure if it plays out that way, just pick a number for x and give that a shot. So we got x plus 3 squared. And a lot of people think that it is, x squared plus 3 squared. So that would be x squared plus 9. So we're going to put that to the test. So here on the left-hand side, so if we plug in 1, that would be 1 plus 3, which is 4. So that is 4 squared. 4 times 4 is 16. And now we're going to check. We're going to see if the right side does that. So 1 times 1, so 1 squared is 1. Oh no! 1 plus 9 isn't 16. 1 plus 9 is 10. So these two things are not equal. They don't work the same. So do not just distribute that square. That's not how that works. Don't do it. I promise you, it doesn't work that way. And in the very, very small cases where it does work that way, you're usually plugging in 0 or 1 anyway. Like it's just 0. So it doesn't matter if you square it. So in the few cases where it does actually work that way, you're not going to see those for problems. I guarantee it. So anyway, so now let's do this the correct way. Let's do this in a way that's going to make it work. So when we're talking about squares, square means that you take that number, you multiply it by itself. So just like before, we were talking about distribution. X plus 3 is a number. I'm not sure which number at the moment. X could be, anything. So it could be any number. But it is, x plus 3 is a number. It is a single number. So what we're going to do is we're going to do x plus 3 because this is the number that we're working with. And we're going to multiply it by itself. So itself would be x plus 3. And now you might be thinking to yourself, oh, okay, so now that I've split it up, I just do FOIL. And this time, Mr. Updegrove is going to do FOIL correctly. So first would be x squared. So first, outer. So outer would be that. So x times positive 3, so that'd be plus 3x. So that's outer. Inner, so that would be these guys. So that would be plus 3x. And then last, so that would be plus 3 times plus 3, so it's going to be plus 9. Okay. So that means we get to x squared plus 6x plus 9. Okay, so because we simplified our like terms, these are only like terms, so we added them together and get plus 6. So, and yes, you can do it this way, but that is a little bit slow. That takes a little bit of time. So what we're going to do now to see if we can do this a little bit faster is we're going to do this just with letters. We're just going to use letters, which I know everybody's so happy when you do the math with only letters. Don't worry, though. Don't worry. We're only going to do it for a little bit. So let's say I got 2 terms. So I got a plus b, and then I'm squaring it. Okay, so as we just established, that'll be a plus b times a plus b. So we're squaring this binomial. That's what we're doing. So a times a, that would be a squared, plus a times b, so that would be a times b. Then b times a, which is the same as a times b. You can write whichever letter first you want. And then b times b would be b squared. So we get a squared plus 2 times a times b. And the reason it's 2 is because 1 plus 1 is 2. So, we combine them. And then plus b squared. So what this is really saying in English is, so we have our first term, and we start by squaring that term. Then, or actually here, let me use different colors so I make this a little clearer. So we got our first term, and we square that term. Okay, excellent. And then we've got our second term, and we do square that part. So this is what most people do. They think, oh, square plus square. But actually, in the middle, you need to do this times the other guy times 2. So this is all nice and well to see with these colors, but let's actually put it in action. Let's practice a little bit with this. So let's say we got x plus 3. And we're squaring that. So we already know the answer to this guy, so I'm just using it as reference so we can double check, make sure it works. So according to this, square the first guy. So the first guy is x, so that would be x squared, okay? Then, we take that guy, we square that guy, so 3 times 3, okay, that's 9. So we got 9 on the end. And then we do this times that times 2. Okay, so x times 3, that would be 3x. 3x times 2 is going to be 6x, so we're going to add that in the middle. And would you look at that? That is the exact same answer that we got before. So whenever you're doing a square binomial, square the first, square the last, and then first times second, double it. That's the way we want to make this work. So let's do one more just to make sure we got a solid example of that. So square the first, square the second, then multiply them and double. So let's say we've got x minus y. No, not minus y. We'll do minus 4. I said we wouldn't keep using letters, and I don't want to be a liar. So, okay. So first term, x. Okay. So square that, and that is x squared. Okay. So next number. So we've got negative 4. So 4 times 4 is 16. Negative times negative is positive. Okay. So then we multiply here. So it's x times negative 4 times 2. So x times negative 4 is going to be negative 4x times 2. That's going to be negative 8x. And so we put that in there. So we have minus 8x. And there we go. That is indeed the correct answer. If you would like to... Oh, I forgot to put the square up there. I'm sorry. So if you'd like to check this using the other methods, feel free to just, write it on a piece of paper. You just write x minus 4 times x minus 4. And then go ahead and multiply that out. You'll find that you get this as your answer. So anytime we do squares, just, square the first term, square the second term, then multiply and double. And you'll be perfectly fine. So this is a nice, neat little way to do binomials a bit faster. There's nothing wrong with doing the long way around where you do, it times itself and then you multiply the whole thing out. Nothing wrong with that. It just takes a little bit more time. And, sometimes when you're on a test, you want to make sure you have that extra time. So it's a good way to save yourself some time on that front. So that's squaring binomials. So now let's talk about multiplying polynomials. So a polynomial is like a binomial, except there's more than 2 terms. So let's go to the board and just look at what two polynomials would look like. So let's look at two polynomials that we might multiply. So let's say we have x minus 3. So we'll say our first one's a binomial. That's fine. And in the second one, we'll have x squared plus 2x minus 1. Okay, so we got this. Oh boy, now we got to multiply all this. So FOIL isn't going to work here because now we got more than 3 terms in the other one. But the idea of FOIL still works. So the idea of FOIL is you take your first term and you multiply it by every term that's there. So x times x squared, that would be x cubed. And then x times 2x, that would be plus 2x squared. And then x times negative 1, well, that would be a minus x. And then you multiply by your second term, so negative 3 times x squared, so it's a minus 3x squared. And then negative 3 times 2x, that's going to be a negative 6x. And then negative 3 times negative 1, that's going to be a positive 3. Okay, so the idea of FOIL, so you do your first one times everything, and then your second one times everything, that applies for right now, because we just have 2 terms to work with. And then, of course, we could combine our like terms. So here and here, we've got some like terms. So x cubed has no like terms. Positive 2 minus 3, so that's going to be a minus 1x square. And then in terms of x's, we got a negative 1 there and a negative 6 there. So negative 1 minus 6, that's going to be a negative 7x. And then, of course, we just have the plus 3 on the end. So this would be the answer. So the principle of FOIL, you just do each of these times each of those. You can still go that route of, drawing the lines and multiplying them as we did just here. The only place you might run into a couple of problems is whenever both of them are 3 or more. So let's do a bigger one. Let's say we have x squared minus 3x plus 2. And by the way, I'm just making all these up on the fly. If you want to make up your own problems, just change the 2 numbers on the end, change the positives, negatives, use whatever numbers you like. You can make them as big or small as you want those to work. And then the x squared plus, let's say 4x plus 4. Okay, so now with FOIL, you might run into a bit of a paper issue. So this is something you can still do. It just might look a bit messy because, you do your first 3, then you go to do your second 3, and now, oh my goodness, now I have to do a third 3, and it's like, well, if I draw them on top, they're going to go over those lines. That's kind of messy. If I do them on bottom, they're going to run over those lines. That's kind of messy. So you can still do the foiling idea. It's just that writing it might be a bit messy. And so you could always do what I did before. So you remember how I underlined stuff? Yeah, so now you do the x times those 3, write them down, and then you could do x times the second 3, the negative 3x times the second 3, and you write those down. And then you can do the 2 tick marks, so you do the 2 times everything, and then you can write those down as well. But as you might have noticed, that is a very, it's a bit of a longer process, and there's not as much structure to it. So we are now going to take a step back, and we're going to do something with a little bit more structure. So now we're going back to the good old box. So we got the big box here, okay? And we're going to put this first one on top. So we got x squared minus 3x plus 2 multiplied by x squared plus 4x plus 4. Okay, so now we draw the lines in the box. So now instead of a 2 by 2 box, we're going to have a 3 by 3 box. So the box is always getting bigger, but that's okay. That's fine. It can do that. There's no problems with that. So now we do the same thing. So x squared times x squared, that's going to be x to the 4th. X squared, let's do, for the next one, let's do x squared times negative 3x. So that'll be negative 3. And remember, this is x to the 1st. So we'd have negative 3x to the 3rd. And then for our last one, let's do, yeah, let's go ahead and do yellow. We'll do, positive 2 times x squared. So it'll be a positive 2x squared. Okay. So next up on the chopping block, let's go ahead and do these guys. And, oh no, not green. Let's do blue. Let's do blue. So we got 4x times x squared. And remember, this is 4x to the first, so that's going to give us a positive 4x cubed. And then last, but certainly not least, let's do some purple. So last but not least, so we're doing positive 4 times x squared, so it's going to be a positive 4x squared. Okay, so now we're multiplying everything else. So in the middle, I probably shouldn't have done purple. Well, I'll do this kind of shade so that we get something different. So we've got, actually, you know what? Here, I'll just change that from purple to, let's make it gray. We'll make it gray. So 4x squared. So no change there. I just want to make the colors line up, look pretty. So we got 4x now times negative 3x. So 4 times negative 3, that's a negative 12. And then x times x, that will be x squared. Very good. So now for this box over here, 4x times 2, so that's going to be 8x, and that's going to be positive, because positive times positive is positive. Then down here, so we're going to do a darker red. So 4 times negative 3x, that's going to be a negative 12x that we got there. And then last but not least, we're going to go for a bit of a darker yellow, so orange if you will. And then we'll do 4 times 2, which would be 8. This is positive. Now, one thing you probably noticed is that across the diagonals, the powers are the same. And this is something that's very good about the box method, is it tends to, not always, but it tends to line up your like terms so you can deal with them one at a time. So our first term is x to the 4th, nothing quite like it, so we're fine with that. So next, our like terms are going to be positive 4x to the 3rd and negative 3x to the 3rd. So a positive 4 minus 3, that's going to be a positive 1. So we have plus 1x to the 3rd. And now next up, we got positive 2x squared, negative 12x squared, and a positive 4x squared. So let's do this left to right. So positive 4 minus 12, that would be a negative 8x squared. And then negative 8 plus 2, that's going to be a positive, or I'm sorry, negative 8 plus 2 is going to be a negative 6x squared. So if you want to write out this whole thing, you can write them all out. It just tends to take space. I'll do that at the end so that you can see that it all works out. But anyway, so moving on to just our x's. So negative 12x plus 8x. So negative 12 plus 8, that's a negative 4x. And then we'll do plus 8 at the end. So this would be the simplified version done using our little arrows to combine our like terms. But let's say we didn't do that. Let's say, we got all these. We don't want to have to deal with all these arrows. Let's just write it out from left to right. Okay, well, your wish is my command. So we got x to the 4th minus 3x to the 3rd plus 2x squared plus 4x to the 3rd minus 12x squared plus 8x plus 4x squared minus 12x plus 8. So this is what happens when I write out every single term in the box, just, left to right, top to bottom, the way you would if you were reading, a sentence on a piece of paper in English. So now, oh my goodness, that's so many terms. How am I going to deal with all these terms? Well, let's just start with, okay, so we got x to the 4th. So x to the 4th is by itself. Fair enough. So now we're going to underline all of our cube terms, and we only have 2 of them. So it's like, okay, so I only have to deal with 2 of those at a time. That's manageable. Okay. So then we're going to underline all of our x squared terms. So there's x squared, there's another x squared. Okay, there's only 3 of those. We can handle that. Then we're going to underline our just x terms. Okay, so just x. Oh, there's only 2 of those. Okay, so this is much better. We can do this. So x to the 4th, it comes down. It's just x to the 4th. So now we're dealing with our squares. So we got negative 3x cubed plus 4x cubed. Okay, so that's going to be a positive 1x cubed. Fair enough. That's not so bad. So then we got our oranges. So we got a positive 2x squared minus 12x squared plus 4x squared. Okay, so 2 minus 12, that'll be a negative 10x squared. And then we add plus 4x squared on the end. So negative 10 plus 4, that's going to be a negative 6x squared. Okay, so far, so good. Now, last, we've got the plus 8x minus 12x. So 8 minus 12, that's going to be negative 4x. And then, of course, way over here on the blue, we've got plus 8. So we'll write plus 8. And as you can see, this guy and this guy are the exact same. So if you want to write out all the terms and you don't want to have to do the arrows, that is more than fine. That is perfectly fine. You can do it either way. As long as you combine your like terms, you're going to get the correct answer at the end of the day. So don't worry too much about, oh, you know, I've got this whole box. What if the diagonals don't match up? Don't worry about it. Just write them all out. Combine your like terms. You'll be just fine. Okay, and so this is multiplying polynomials. You got to do every term by every other term. And this is where I think the box method shines a bit more. Before, you know, making a 2 by 2, I think a lot of people don't like having to draw the box when it's like, well, it's 4 pieces. 4 pieces is easy to keep track of. And then they get to something like this, and it's like 9 pieces. Oh my goodness, 9 is a lot more than 4. That's a lot more pieces that I have to keep track of. I can't keep track of all of that in my head. So what do people do? They draw a neat little box that allows them to just line up and multiply it row by column so they can get all their terms and then combine all of their like terms. And there's nothing wrong with that. That's a good way to do it. It's a nice way to organize all of that information. So so yeah, we've gone over multiplying polynomials. We've gone over the 2 main ways to do it. And so now we can move forward into, okay, so now we have reached the end of this whole, multiplying these terms in parentheses that have, more than one part. A lot of distributing going on in this one. This is the question we're going to go for in the synchronous hours. And next time we'll be doing, we'll talk about dividing. So we did a bunch of multiplying, then we'll start talking about how to divide these things. So that's it for this video. I will see you in the next one.